And he made this slide, I think, in around 2018, to show where natural language processing stands or stood at that time. And it's interesting because what is here marked as still really hard, question answering, paraphrasing, summarization, and dialogue, that's essentially solved with generative large language models like ChatGPT, right? Some of the other tasks are actually still hard, but that part on the right that was basically really, really hard just like 6 years ago is essentially solved. So progress has been enormous, and large language models, whether that's BERT type models or GPTs, they have boosted performance in NLP incredibly. And then multimodal large language models have boosted capabilities in computer vision. And we're seeing it already, and I'm sure this is what's going to happen, is that digital humanities tasks will follow a similar path. But we should also try to learn from what happened in other fields and anticipate this, and I will come back to that in the end. So large language models are really everywhere in digital humanities now. If you look at papers at some of the major venues, many papers routinely or repeatedly, or many papers use large language models. At the Digital Humanities Conference, you see that. At the Computational Humanities Research Conference, which is a bit more technically oriented, you see that obviously, it's very normal. And at the Journal of Computational Literary Studies, we see it as well. And there's a wide range of issues that are addressed using large language models. Of course, natural language processing tasks that support DH research, that's where it's used, but also for like complex DH-oriented annotation tasks. For text encoding, people use it to structure data, for information extraction, for text and image analysis, and also for things like getting help when you program things, because the generative large language models, the GPTs, are actually quite good now, also in helping you with your programming or with Sparkle queries and things like that. But of course, there are also some problematic issues, and we will see them pop up in the use cases. For example, the problem of explainability. It's a huge topic, obviously. It's a research domain in itself, but it is a real problem also for digital humanities, especially for digital humanities, I would say, because we're not just interested in performance, we're also interested in understanding the domain. That's actually the main point. There's also the problem of reproducibility in connection to open science. How can we repeat or can others repeat our research if we use some online service that is bound to change all the time and that is unpredictable to some extent in the way it works? And there's the sustainability issue, hardware requirements, energy requirements that we should also take into account. But so I don't want to talk about these like in the abstract. I really want to talk about them based on concrete research. And that's why we finally now turn to the use cases where we used large language model in Trier in research recently, and then try to derive some lessons from that. So the first use case is a project on multilingual stylometry. And you see two references here where you can go to see more information on this. But so this use case is about a particular computational method of text analysis. And stylometry is actually one of the oldest paradigms in digital humanities, and it's all about authorship attribution. Essentially, the idea that the author of an anonymous text can be identified based on a comparison of the word frequency profiles of the disputed text compared to the frequency profiles of multiple other texts that are, by candidate authors. And it's one of the high-profile methods in digital humanities, and as such, I'm sure you have heard about them. And so I just remind you here some of those high-profile cases, like, of course, work around William Shakespeare and new attributions proposed by Craig and Kinney, for example, or very famous writer Joan K. Rowling and the case of her pseudonymous novel, The Cuckoo's Calling, and then also famous cases in Europe, Elena Ferrante, a pseudonymous author in Italy, best-selling author in Italy, or a controversy about Molière and Corneille in France. So those are all high-profile stylometry cases, but they are all also single language cases. And so we were interested in looking beyond one language and trying to see how different languages influence stylometric performance. And we did that using corpora from the European Literary Text Collection, which is a multilingual collection of literary texts, of novels. And we chose 4 different languages, English, French, Ukrainian, and Hungarian, in order to find out how language influences the stylometric performance. And this has been done in the past, but with, different types of corpora for each language. And if the corpora are different, have a different composition, different genres in them, different size, different period, and the language is different, then you don't know whether the differences in performance come from language or come from that particular corpus composition. So we wanted to use the same corpus in multiple languages. And for that, we needed to decouple language and corpus composition. And the only way to do that was to use translated corpora. But those are not available. So basically, we used original versions and translations into all 3 other languages. And in order to do that, it's about 360 translations that we needed to do of full, long novels. So we needed to use machine translation and turn to DeepL, the machine translation system developed in Cologne in Germany, which is a deep learning based, as the name suggests, deep learning based machine translation system in order to translate all these novels. And that allowed us to do this kind of research. And we built an interactive showcase that you can look up under the link that you see here in order to investigate this data set. The results, this is a very high level summary of the results for some reasonable settings, but we investigated a wide range of settings and parameters. And that's what the showcase, the interactive showcase, allows to explore more fully. But what you see here is that Hungarian is the easiest corpus. In the bottom right corner with 0.97, so almost perfect performance. That doesn't mean that Hungarian is an easy language for stylometry. It's just that corpus, right? The Ukrainian corpus is the most difficult one with the lowest performance. And the other thing that you see here is that translated corpora are have always somewhat lower performance than the non-translated corpora. And that sort of makes sense, especially because in a way, we didn't use human translated text that might be, different for each author as well, because they're different translators. We basically only had one translator in a sense. So what can we learn from this, first of all? So some affordances. Using DeepL clearly was a game changer for this research. We just couldn't have done it without it, because it would have been extremely time consuming and expensive to translate, to have all these novels translated by human translators. So basically it would have been impossible otherwise. And it's also extremely expensive and complicated to build these corpora, like parallel corpora in 4 languages, from existing translations. I mean, there are translations, but of course not every novel is translated into all the other languages. This meant that we were able to, derive some interesting insights into those stylometric methods. And our paper that we are about to present at the next CHR conference is going to go into that. And basically impossible without large language model-based machine translation, without AI. At the same time, there are some limitations here. So for example, the translations, they are acceptable. I mean, we looked into the translated text, of course, and they are okay, but they're not, they're not mind-blowing or elegant or whatnot. And there are some problems as well. So it works, and I think it's okay, but it's not great. And obviously they are not meant for, for reading. I would still recommend, professionally translated novels if you want to read the translation of these novels. But still, it's useful. The other limitation of this research is, of course, that the deep learning was only in that tool, in using DeepL. The rest of the research and the main part of the research, our stylometric tests, that was just normal machine learning. And here you see why I think it's so important to distinguish, because in the terminology, if you use the broad view of AI of François Chollet, then all of it was AI. but it's not the same kind of AI. Even we just need to make sure that we know what we're talking about. So stylometry is counting words and building word vectors and testing similarities, doing some machine learning, traditional machine learning on that, but it's not large language models. The large language model part is in a different part of the research. And then finally, the limitation that I already alluded to is that each translation pair is performed by one and the same agent, DeepL, the DeepL translation of that particular language pair. And that's a bit unrealistic and maybe a reason why the translations are more homogeneous and therefore more difficult to attribute than would be in a real, like a case with realistic translations. But so that's the first step. Let's look at a different use case. And this one involves direct speech recognition. This is again in the framework of the CLS Infra project, a European project on computational literary studies. And so direct speech recognition is a very typical computational literary studies problem. You want to distinguish in a narrative between what the narrator reports and what the characters speak or say, right? So there's narrative speech and character speech, and also character thoughts. And that's a very fundamental distinction. And there's also more distinctions within character speech, for example, direct speech, indirect speech, free indirect character speech. And there are many reasons why you might want to separate the two and analyze them separately. For example, many people are interested in the question of, how much has the author given an individual voice to each character? And something that I'm very interested in is to see whether the amount of character speech is somehow related to the subgenres of the novel. Like, is there more dialogue in crime fiction than in literary fiction? And that's actually the case. Popular fiction seems to have more dialogue. At least in French, I can say that. So our first attempt, and this is now, I present several attempts to do this. So our own first attempt at this was in 2016 with a corpus of French novels, 19th century, and we focused on direct character speech at the sentence level. And we used a traditional machine learning approach. That meant we needed to do a large amount of feature engineering, first of all. So we distinguished 80 features: punctuation, part of speech, the tempus of the verbs. Is it simple past, or is it present tense, or simple past, or past perfect? Are there imperatives? Are there exclamation marks? All kinds of features, and it required a lot of annotation. So it took us a long time to get all these annotations. And then we trained, we annotated some part of the data manually, and then trained and tested a classifier, which was an SVM, a support vector machine. And the most relevant score was 0.924 here in the right bottom corner. So really good results and interesting to do. And we got all kinds of interesting results also with respect to time period and subgenres. So exactly what we were looking for. But it took us, I would say, at least a year as a team to do this. And then in 2021, some colleagues of mine in Würzburg and Mannheim, they used a large language model-based approach. So with, to approach the same problem just for German, but for German narrative text, very similar problem. With a more sophisticated approach, I would really say, because they focused on various types of character speech, and they took the token level as the basis of analysis. So it's more fine-grained, more precise. And so in their large language model-based approach, they used pre-trained large language models. So models like BERT and FLAIR, pre-trained for German on large corpora. And so then they did some fine-tuning, with manually annotated data. And they had to annotate quite a lot to do extensive training, and then they did their tests. And they obtained the best F1 score for direct speech was 0.87. So slightly below actually our performance, but with this more sophisticated and more challenging setup. So it's not actually worse. It's at least the same. It's probably better. But again, it took a whole project with a team, that ran for multiple years to do this now, to be fair, for multiple types of character speech, but still, I would guess it took them at least a year to do this as well. And now recently, we came back to this question and used a different approach using called setfit. Again, focusing on direct character speech, just sentence-based, and using the setfit approach from Hugging Face with sentence transformers fine-tuning. So basically, you take pre-trained BERT-based sentence transformers, and then you use few short learning. So you only need a very small amount of training data. And doing this, doing it in this way resulted in an F1 score, depending on the scenario, between 89 and 93. So again, same ballpark, same kind of performance, which is great, of course. And the key is something else. And so what can we learn from this? First of all, progress is indeed impressive. And now you will say, where's the progress? The performance was the same. And it's true, the performance did not change so much. It remained pretty much on a similar level. And it's actually interesting, it seems to be that it's really hard to go beyond that 92, 93, F1 score level. And I wonder why there's this plateau, and I hope someone will break through it soon. But the real difference is in time and effort needed. The setfit approach that I just talked about in the last, as the last step, took me alone just a few days. Whereas for the other two approaches, there were teams working on it for at least months, if not years. So there's a huge difference in effort. And that's, of course, a game changer. And one of the differences is the amount of training data. There's very little manual annotation needed and no handcrafted features, because deep learning based or large language models have a very sophisticated feature representation just by being pre-trained. However, there's also a big concern, which is explainability. In our very first model from 2016, we had direct, very immediate and easy insight into the reasons and into the mechanisms of direct speech, because we could look at the feature weights. We used linear SVMs, where you can simply read out the feature weights, and you can see what features, which ones among those 80 features that we modeled are strong indicators for direct speech or against direct speech. And that helped us better understand how direct speech works in our corpus. And that's really trivial in these traditional machine learning approach. And it's much more complicated in a deep learning or large language model approach, because the mechanism is not transparent. You don't know what is going on in your neural network. And so you need sophisticated methods of inspecting the model, of visualizing the features, of extracting features that are actually beyond what we were able to do. And so, time saved, but less insight. So that means to me that in this context, large language models are useful as a tool to get to get this annotation. And then we can look at the annotation, and it will be interesting, of course, but not so useful to understand the underlying phenomenon. How does direct speech really work? And that's a trade-off. But let's move on to the last use case, and I try to be quick. So this one is not about text, not about literary studies. It's about historical wine labels. And there's a reference publication, but it's in German, unfortunately. I'm sorry about that. And this is part of a project that we are running at the moment at Tree University. And so that just so that you see how this looks like, we have several collections of these historical wine labels. And this is how they look like, for example. So these are from the beginning of the 20th century, end of the 19th century. There are some, really old ones as well, going back to about 8. The oldest one is probably from the early 19th century, 1811, 1820s. That's when this practice starts. And you see that they have bad quality because they are really old. The writing, the printing is kind of washed out. But we also have collections of more modern labels like these. But here you can imagine that the object detection, for example, to see what is on there is not easy because it's pretty artistic. The butterfly on the top right, for example. We can see it. And there's the text as well that helps us, but not easy to recognize. And so the goal in that project is to build a knowledge graph about those wine labels. So using the linked open data paradigm. And one focus of this project is to map things, to map the vineyards in our region, to map the winemakers, the villages, and of course also the labels. And what you see here is all the villages where wine is made in our region, and you can see that it's these winemaking villages, they go along the river. They trace the direction of the river. Here it's difficult to see, but that's basically why there's such a this diagonal. Another focus is on the objects depicted on the labels, and you just saw them. There are all kinds of different objects on these labels, and we're interested to see whether there are certain trends over time, or whether there are trends, correlations between certain objects and certain regions, or certain types of wine, or certain periods. And so we need to recognize those objects, and it's pretty tough, as you just saw, also because there's text and image like mixed into each other. So the goal is to use large language models to annotate our collection of wine labels and then feed that information into a knowledge graph. So we're combining large language models and knowledge graphs, which are usually seen as opposites in a way, at least contrasting approaches. But we try to combine them here. What we get then is this kind of table where we have labels with the wine names and, for example, the year of the wine label, and then a list of objects. For each wine label, we have a list of objects, and then more information in this database. It's a Wikibase instance, but our own Wikibase instance. And so now I want to just talk quickly a bit about how we got this information. So the first tests, we did them with ChatGPT in November 2023, so about a year ago. That was ChatGPT 4 with the ADA plugin. It was called Advanced Data Analysis, I think, that plugin. And the prompt was very simple and pretty amateurish, I would say, now looking back. So what objects, things, animals, text, and design elements do you recognize in this image? And we got the output that you see on the right. And it's a bit too detailed probably to look into it now, but certainly the OCR was really impressive, including very difficult to see names here written on the mountain on the top right, for example, or even the river here is not easy to recognize. And then also some interesting inferences, because the ChatGPT said about the river here that it's probably the Mosel River. And it's true, but it's not visible from the river. You cannot recognize one particular river from such an image. But because of the context, because Mosel is written elsewhere on the label. You see it on the top left on the label. But this is completely unstructured prose and very difficult to work with in a database, perspective. So we needed to move beyond that. And so this year, actually recently, we used another approach, which is called custom GPT. So again, using ChatGPT version 4.0 now in October, so just recently. But we did a number of changes. So for example, we used much more detailed instructions. So a more precise prompt. And this is just one example. We had a number of different prompts with different prompting strategies. And crucially, there's a controlled vocabulary of depicted objects, about 100 items that are recurring objects. It's a bit, it's not random. There's a limited number of things that people like to show on wine labels. And the instruction included in the custom GPT instruction to use JSON output as default. And yes, there are a lot of improvements. For example, the results are much less like conversational, and that's more useful to us, at least in our perspective of wanting to feed a knowledge base. And the items that I mentioned here, you see, I hope you can see this. There's barrel, people, wine glass, and grapevine. They are actually part of the vocabulary. So, you upload a CSV file as part of the custom GPT instructions. So that's good. And we have this very simple JSON that's easy to handle. But there are also some persisting issues. For example, the instructions are just applied very inconsistently. After a while, it just wanders off and does what it wants in a way. Also, and that's really sort of annoying, let's say, is that the QIDs, so these identifiers here, the Q105, Q120, they are just incorrect. And it's impossible to get the model to really stick to the IDs that are in the data, that are in the custom GPT's information set. And of course, the big problem is this is not reproducible. If you take the same label and the same, custom GPT model that you can use also, and you use the same instructions, you may get some other results. So it's just not reproducible. And so that's also a problem. So some lessons learned from this one. Some affordances, first of all. So compared to systems from about 5 years ago, if you look at separate OCR for this kind of challenging data set, and also object detection, computer vision, there are libraries for that, and we've experimented with them in the past. Compared to those systems from just a few years ago, progress is impressive. The OCR and the object detection is impressive. And of course, the accessibility is very high. It's not difficult to create such a custom GPT if you stick to the ChatGPT version, and it is paid, so it's not open in that free. It's not open in the sense of being free, but it is still relatively accessible. You don't need specialized hardware. You don't need to buy a server, things like that. And it's actually a good way to feed some information into our Wikibase. So it is useful for our approach. However, it's really hard to constrain ChatGPT to give us formalized knowledge. And, maybe that's because it's a misunderstanding. ChatGPT is good at producing conversational prose. That's what it's designed for. That's what it's optimized for. And it's sort of trying to constrain it and bend it into this, give us JSON with identifiers. Maybe that's just not a good idea, or a misunderstanding of what ChatGPT is for. And then another limitation is that if we say, okay, we don't want to use ChatGPT, we want to use a local desktop, model, then first of all, we have problems of performance. The free desktop models are just not as good, unfortunately. Some of them require a lot more hardware than just running it in your browser, obviously. And so that's not trivial to make that step. But I do think that the way forward is probably to use ChatGPT for free prose descriptions of labels that we can feed as a full text into our system, that will support searching, that will act as a sort of alternative text description, image description for people who maybe cannot see the labels as well, but then use more traditional object detection, enhanced by deep learning, but a bit more down to earth, let's say, to feed our knowledge graph. And that's the double approach that we may follow now. Okay, I come to my conclusion. Some advantages and challenges of LLMs in digital humanities, and of course of AI as well, but just this particular type of AI. So the advantages are really, first of all, the progress is just impressive. There's higher performance, notably higher performance in some tasks. There's much lower development time on other tasks. For example, because we don't need to handcraft features anymore, and that saves a lot of time. Especially for text, we have, through the pre-trained contextual large language models like BERT, we have such a good representation of meaning in context that is really helpful. It's something we want, that we need in computational literary studies. Not just look at the word forms, but look at meaning in context and use that for computations. That it's just wonderful. It's really a big progress. And I do think that the context spans will continue to grow, from just 10-word windows, we went to sentences, to paragraphs, and the next step is entire novels. And one thing that CLS is like the holy grail of CLS is plot, storylines. And if things develop the way they have developed over the last 5 years, we're going to get there soon, and it will be really fascinating. So I think one promising approach could be to say, okay, digital humanities is using large language models for annotation, information extraction, and then feed that into metadata tables, databases, knowledge graphs, and analyze those. And at the same time, and in parallel, maybe natural language processing can use knowledge graphs, for example, via knowledge graph embeddings, which is a subfield of its own, to feed factual knowledge into large language models, and in that sense improve them, or in this way improve their factuality, and in this way also improve information extraction for digital humanities. So in this sort of, in a collaborative loop in a way. So I would be excited to see that happen, or to participate in this process. But there are also some challenges. We have seen that there's a challenge of fairness and accessibility, because if you want to do this in a reproducible way with local models on your own machines, then the hardware requirements are really high, the energy requirements can be really high, and that results in high cost. That's also connected to the sustainability challenge. There are very high energy needs, including when you use ChatGPT, because it's not your energy cost, but somewhere the energy cost and the energy need happens. That is in the data centers of the big companies that offer the publicly available LLMs. So for me, that means we should think twice before using large language models just for everything, and think about what level of sophistication do we really need, and what can we work with. And then there's explainability, as we have seen in the case of the direct speech. It's just much harder in deep learning and large language models than it was or is in traditional machine learning. And the open science aspect, most large language models are not open source. And then because of that, because they're cloud-based, they're not reproducible, they're not transparent. And we really need to support and foster open source and use open source large language models. And so we are in the process of trying to make that switch. And there are many great models. It's not that it's impossible. It's just, it's really important to do that consciously. And to finish, and this is my last slide, we should learn from the past. Like there was big data, big data was a big thing in like around 2010 in digital humanities. Then came topic model in 2012 or around 2012, word embeddings a few years later, and now we have ChatGPT, which is the big thing, and AI and LLMs. And I think what we can learn here is that with big data and topic modeling and word embeddings, to some extent, digital humanities fell into a trap here. So, we said computer science, they have big data, we need that too. And then with topic modeling, same thing, we need that, we want to do that, and word embeddings. And I don't exclude myself. I was in a project where we said, yes, we are going to use big data. I did a lot of topic modeling, and I still like topic modeling, and I think word embeddings are great, But the problem is that topic modeling and word embeddings, or word2vec, for example, was designed to address a challenge that only arises when you have huge amounts of data. The main thing of word2vec was to develop methods of training word embeddings that would still be efficient with huge amounts of data. And then we took those models, applied them to our tiny data sets, and thought, what do we do now? The data set is too small. My topic modeling doesn't look nice. My word embeddings don't make any sense. We need more data. So, and that's kind of that's not a productive loop. Instead, we should have looked at, if we want to have good word embeddings, what is the best method to train them when we only have small corpora? And the answer is not word2vec. The answer is, more traditional methods of training, of creating word embeddings. And so let's not fall into the same trap with GPT and large language models. For example, this trap that we fell into with the wine labels. Now we have this conversational agent, but that's not what we want. So we need to try to force it into something else, into being something else. That's not productive. So for that particular task, we should look at something else. So the last thing that really is important to me is that, this challenge the challenge of digital humanities is not just optimizing F1 scores. It's about a better understanding of our domain. And a black box will never do that for us. Thank you. So I unshared my screen and I will mute myself. Thank you.
academic works such as Protestantism and modernity among the Hmong in China, the digital humanities approach to historical texts, and the application of DH tools like DokuSky for scholarly research. So with a big applause, let's welcome our Professor Hu from Taiwan to the stage, please. The operator, can we show the slide presentation from Professor Hu, please?
Thank you.
Thank you. The slide presentation.
Yeah, that's me.
Okay.
Can you show my slide?
Okay.
Good afternoon, ladies and gentlemen, sir, madams, and friends online. I'm honored to have this opportunity to participate in this conference and witness the important moment in the development of digital humanity in Indonesia. The QR code there is my slide, and you can scan it to download, or I will send my slide to the conference, and maybe you can from them. I put some hyperlink inside my slide, and you can just click it to check them more. As Professor Jurey said, I come from Institute of History at National Changhua University of Education. It is an institute which focuses on the development of digital humanity, researches, and education. In the past near almost 20 years, I have become familiar with digital humanity because I joined the digital archives work in Taiwan and worked at Research Center for Digital Humanity about 6 years ago. Therefore, I have participated in the development of many digital humanity tools and platforms. As a humanity researcher, I'm excited to share this story with you. It can be the next. Okay. Should I turn on anything? Yes. The development of digital humanity in Taiwan is different from that in Europe or in the United States. It is because there was a long-term digital archives project supported by the government for more than 2 decades. In this project, our government is used to provide this institution with cultural heritages to carry out digitized works. And a large number of databases are established so that this data can become the foundation for the development of digital humanity today in Taiwan. So we will share with you starting with from the development of process of digital archives here. In 1984, Academia Sinica in Taiwan began the work of automation historical records, converting ancient China historical document into electronic full text. And in 1985, full text input of the China dynasty history was carried out. In 1987, the C-Beta and the Damadrong Institute of Liberal Arts carried out the electronic work of Chinese Buddhist Sutra. In 1998, National Taiwan University started a digital library and a digital museum project. With this experience, the Taiwan government carried out a digital archive project from 2002 to 2012, and thus established a large number of electronic data as a resource available to us. On this foundation, Several important government academic institutions, such as Academia Sinica, the National Palace Museum, or the National Central Library, have started their digital archives project. A large number of material have also been digitized because of this project, and a lot of digital infrastructure was created, such as the establishment of digital standards and the training of digital archives teams also happened during this period. Not only national academic institutions, but also many universities have begun digital archives projects by the support of the government. I would like to highlight the achievement of two important universities here. They are the Research Center for Digital Humanities in the Taiwan University. And the other is the Damadrong Institute of Liberal Arts, which we call them DILA. In fact, these two teams are always help each other and the collaboration together. By the way, this collaboration things is quite normal in Taiwan. It is because we hope not to do the things that are already done by others to waste everybody's time. The famous achievement of DILA is the Digital Buddhist Sutra Online, which DILA worked with the Chinese Buddhist Electronic Text Association. It's called the CBETA here. It is the best quality online Chinese Buddhist sutra at the present time. The library director, Professor Jureynold, Hong Zhenzhou, maybe you know him, and former president, BQ Huimin Fashi are important key people in the digital archives works of the DILA. With the foundation of CBETA, DILA still works on developing the information science of digital Buddhist research right now and build lots of related systems and technology on text mining, AI, machine learning, or other excellent digital humanity tools. The Research Center for Digital Humanity, we call it the RCDH, at the National Taiwan University, I worked there before, was led by distinguished Professor Jie Xiang, my boss, by the way, before, who is also one of the most important people in the development of the digital archives project in Taiwan. The RCDH was held in 2007 and is the main institute in National Taiwan University worked on the digital archive and the digital humanity. We will still find some fruit of this project on the website of National Taiwan University. I left the hyperlink in my slide. If you want, you can click it to take a look. You will see there is a lot of different categories in this digital archives project. Because of the National Taiwan University was founded in the Japanese colonial period, and its former is the Taihok Empire University, Taipei 帝国大学. So they have lots of collections, whatever, in different departments. And this collection became the object when the digital archives project started, such as you can see. It's not very clear, but there will be the specimen, zoology, physics, medical, and I will talk about the historical document. Okay, first is Taiwan's historical document. I will use Danxing Archive as an example. Danxing Archive are administrative archives from the Danshui to Hsinchu. It is in the north of Taiwan during the Qing Dynasty. It is about 80th to 19th century. Such as these two images you can see on my slide. If you like to watch the CSI TV series, maybe you will like to check it. It is just the formal crime scenes investigation document in the Qing Dynasty. In fact, there are just the 3 Qing Dynasty local official archives left right now today to let us know the situation in local government. They are Baodi County, Baodi County in the Hebei province, and the Ba County, Ba-县, in the Sichuan province in mainland China, and the Danxing archives in Taiwan. Whatever quantity of Baodi and the Ba County archives are more than Danxing archives, but the Danxing archive is the only one that has been digitized and with a full text database and totally open to the public. There are more than 4 different versions of Danxing archives database, from the traditional retrieve one to the newest with powerful digital humanity tools. It is because of the research value of these archives. So the Research Center for Digital Humanity always want to use the newest computer science skill to let Danxing database become more useful and more convenient. About anthropology achievement of National Taiwan University, I want to introduce the Taiwan Ethnological Collection in Overseas Museums, TECOM, which was built by the RCDH and Professor Chijui Hu, the former professor of the Department of Anthropology at National Taiwan University. During the early 19th to 20th century, there were lots of missionaries, naturalists, adventurers went to Taiwan and collected lots of artifacts, documents, and took many photos. After they back to their hometown, these collections finally preserved by the museum of their countries. Lots of ethnological collections were in overseas museums. So Professor Chijui Hu tried to find these collections and digitize them by taking photos and build a TECOM with RCDH. The meaning of this database is to show the living situation of Taiwanese, not only the Han people, but also the aboriginals. We can use these collections photos to know their life in that period. More important is, in the past, lots of scholars thought the history of Taiwan's material civilization collection began with the Japanese colonial period. But with this database, it shows that it begins in the early 19th century by these Western foreigners. That will be some achievements that may be made by National Taiwan University during the digital archive period in Taiwan. From 2002 to 2012, lots of achievements have been preserved by the Digital Archive project. When the project ended in 2012, many institutes and universities are aware that these practical digital archives should be used for more meaningful approaches to let this achievement become practical data. However, what we faced is not without digital archives. It is too much information from this database that were built during this digital archives period. For example, if we query the word natural science, we call it 博物 there, in the database of Chinese historical documents database, we may get about 40,000, maybe you can see there, 40,000 results. It may not help us to do any kind of research and even become a confusing situation. I want to share an example with you. I wonder how many people still like to visit the library now. What do most students usually do now if they want to find a book in the library? Yes, they just check it on the internet, right? And they will find the number of the book. And some library, they can just we just press some buttons on my laptop or my computer and get the book at the library counter a few hours later. Borrowing books is just like using the vending machine. Okay, I will show that picture in the left. You can see if we will go to the library, maybe we just use the vending machine to get the book that we want. But think back to how we used library in the past. Maybe just like the picture in the right side, okay? We will go to the bookshelves and find the book we want. And then we will find that the book near this book are actually help to us for our research. So we will discover the context between these books. This is why we need to use something called context discovery system. Most of the database built by the Research Center for Digital Humanity are good sample for explain what is context discovery center. It is because we try to use some tricks to help users discover the contextual relationship between the data in the database. So you can also click the hyperlink to find that. The results presented from these tricks allowed users to conduct further researches, such as a timeline. You can see, you can just observe the peak there of the timeline of the document, and we might be curious about what happened in these years or that period. In that timeline, each bar represents how many search results there are at this time point. We use these visual aids to help people notice that there should be some story at this peak point in time. Likewise, we use the word cloud to observe the terms and ask why someone or something always be mentioned in this document or in the novels. On the other hand, geographic information system is also a good tool to help us to find the spot on the map or the route someone has passed before. You can see just in the left picture, it is a missionary. He went in Taiwan, his spot in 1875. And in the right picture, it is the route that he just passed by. By showing this live footpoints of the diary owner on the map, we can learn about their life map. We also developed some tools for helping users to do text mining. Here is an interesting tool called the prefix and the suffix search. Professor Xiang always liked to use this function to explain how to find how he find all kinds of the silver used in the landed in the Taiwan before. For example, we query with the keyword silver in, and the system will find out all the words in front of the silver. So it shows many different kinds of the silvers in all the landed in the systems, such as 佛银, 佛面银, 佛头银, 翻佛银, 佛翻银. What is that? All this silver is Mexican silvers. And we can calculate the turn frequency to know Mexican silver seems to be a predominant currency used in land trade in Taiwan during the 80s to 90th century. With these useful and powerful tools in context discovery system, is there still any problems for our research? There is another, however. Although the context discovery database is easy to use, the database tools are tied to this data and cannot be used to process data from other databases. Maybe you will ask, this context discovery system is awesome. Can I put some material that I'm working on to use your tool to do the same analysis for me? Maybe I will say, okay, but how much you can pay? You know, it is because each of the context discovery system is designed for the data inside. So the construct is follow the format of this data. When people ask for adding new data, the format of the new one might be quite different. And sometimes the information expert will convince you to build a new one for your own database. This is why we want to go to the next step in Taiwan. We call it Personal Digital Humanity Platform. What is the concept of the digital humanity platform? I always said that a digital humanity platform is just like a kitchen. If you want to cook a good meal, you should have a good kitchen. And in a good kitchen, there will be some external condition and inner condition. Just like maybe you need open and a big space, and you need a good kitchenware, or you need a source for your cooking, right? It's just the external condition. But the most important is the inner condition. We need a good chef. And we need the good chef bring the food resource ingredients to come to the kitchen, and he or she will cook a delicious meal. And the digital humanity platform is quite the same. There will be some external condition and an inner condition too. For example, we want this digital humanity platform with the open and big cloud space. And this platform there will lots of different kinds of good digital humanity tools to help us to analyze our data. And we need a source. Maybe we want to add, mark up some text in our data, or we want to add the metadata to this data, to our data. So we will need this kind of the tool to help us. But the most important still is the inner condition. We need good researchers, just like you all here. And you bring your material, of course, electronic files. You bring that to the digital humanity platform and use the tool inside, and you can just use it to cook a delicious meal and wonderful research result. Here are some digital humanity platforms that are now commonly used. The first is I will show you later the DocuSky collaboration platform. And the second one is developed by the Academia Sinica in Taiwan. It is also the digital humanity platform. The third one here is the CBeta. It's just invented by the Dampa literal art. And there will be the markers for tag, your text, and the visualization Pladio and the CText. For example, CBeta research platform is built by Dila, and it is based on the resource of the Chinese Buddhist Sutra. Also, it provides some function that you can just upload the material you have, and you can do some digital humanity analysis. And the other one is DocuSky. The full name of the DocuSky is DocuSky Collaboration Platform. It is designed by the Research Center for Digital Humanity and the CSIE of National Taiwan University. It is led by Professor Jie Xiang and developed by the Dr. Xie Changdu. The concept of DocuSky is a platform for digital humanity research. It allows researchers to construct a personal database and let users have full control over their database content. Also, it provides digital tools for analysis and visualization. The DocuSky gives its users a way to open their personal database to the public. Furthermore, what can DocuSky exactly do for you? First, DocuSky can get the text from several online text repositories, such as the CBeta Buddhist Canon I just mentioned, CText from the Donald Sturgeon, and can report from Kyoto University, or the Wikisource, or the Shrine from Max Planck Institute in Germany. We download these texts from them and convert it into the format that DocuSky can use automatically. And on the other hand, you can see the right side, researchers may have their own materials, such as some texts they get from the internet or type from archives or libraries. Sometimes they will be the text file or the table file, or maybe we just mentioned the markers. We can just mark up something in the text. And all these different format files can be converted to the format called .xml, which is suitable for upload to DocuSky for building your own database by several converters inside the DocuSky. Besides, DocuSky has some visualization tools, such as DocuSky can calculate text or metadata inside the document and show the text information as the word cloud or the pie chart. If the document have time information, DocuSky can also show for you, just here. And the prefix and the suffix function can help us to do text mining. And I think maybe you still remember the case of the Mexican silver. Moreover, DocuSky also connects to several digital humanity tools through API. We may use these tools to analyze the file that uploaded to DocuSky became database. Or you can just upload the .xml format file to these tools and do the analyze or other visualization, such as the turn occurrence, maybe the geographic information, maybe the turn statistic, or the align reading, and more. Many digital humanities scholars have used the DocuSky as a model to build various context discovery systems. They use maybe diary, maybe medical book, local gazetteer, or Buddhist temple chronicles. And these databases are open to the public through DocuSky openness policies right now. In fact, we try to use different kind of the genre as a different example to test the DocuSky and even in different kind of language. By the inspiration of the concept of the digital humanity platform, I want to introduce something that happened at my institute, Changhua University of Education. Our institute is a famous one that teaches GIS tools skills in Taiwan. Every student should pass the class of GIS before they graduate. And now they have to learn how to use DocuSky so they can graduate. We also found the research center of digital humanity and public history several years ago, and we hosted the International Conference of Digital Archives and the Digital Humanity in 2021. We also teach digital humanity tools and produce many digital humanity products. And here in this slide on this page, we can see the digital humanity achievement of our institute. Included here it is a land survey GIS system from the Japanese colonial period. And the platform that can just draw the social network analysis chart and a semantic analysis platform. And here in the corner in the bottom, it is a context discovery system for the diary of George Leslie Mackay, who was a famous missionary in Taiwan in late 19th century to early 20th century. And there will be the line reading system for the four Gospels of New Testament of Christian Bible. And there will be two guide work system based on the local history story, which was built by me and my students in a semesters. If you have downloaded my slider, you are welcome to click these links. As I mentioned above, digital humanity research in Taiwan is based on more than 20 years of digital archives achievement. Using this digital result allowed the digital humanity researchers to obtain useful research material. So these digital files should be the foundation and the infrastructure of the progress in digital humanity in Taiwan. Here are some data of the achievement during this year. From 2002 to 2012, we have already made 320,000 pieces of artifact painting and specimen, and 94,000 volumes of the books, texts, and the scriptures. and about 60 million pages of the archives, maps, photos, and about 9,000 hours of the video data. In order to gather more partners in digital humanity researchers, Taiwan has held an international conference on digital archives and the digital humanity. We call it DADH, and it will be held every year since 2009. And this year's DADH in December will be the 5th annual conference. Through the annual digital archive and digital humanity conference gathering, we found that many researchers have a high interest in digital humanities. Therefore, in 2016, we formed the Taiwanese Association for Digital Humanity, and this association became the member of Alliance of Digital Humanity Organization, ADHO, in 2018. This makes the association more international. However, when these scholars who conduct digital humanities research submit their papers for publication, they often encounter difficulties. Why? Humanities journals think this is a kind of paper in the field of engineering. And the journals in the field of engineering think it is a paper for the humanity field. Therefore, in 2018, Taiwanese Association for Digital Humanity began to publish its own journals. It's called the Journal of Digital Archives and the Digital Humanity, which gave digital humanity scholars a place to publish. And through this journal, more research results can be seen here. Okay, to sum up, through this talk, we discuss about a journey from digital archives to digital humanity to the digital humanity platform. Not only to show the concept developed during the last few decades and also know the achievement of this period. On the other hand, the digital humanity progress in Taiwan is a journey from central government, just like the National Central Library or Academia Sinica or the National Palace Museum, to the universities, such as we mentioned, like the Research Center for Digital Humanity in Taiwan University, or the DILA, or the institute I belong in the Changhua University of Education. And then finally, every scholar or researchers to do what they want to research through the personal digital humanity platform. So it is also a journey from the central government to the universities to individual. On the contrary, in the beginning, there were originally only few digital humanity researchers. But because of the annual Digital Archive and Digital Humanity International Conference and the publication of a Journal of DADH, these lonely researchers were no longer alone. Through exchange at the conference and the publication in journals, these researchers participants found each other in TADH and become a group, achieving many things today. We are looking forward to see the new generation of research process come, and we believe it will be very soon, and so do in Indonesia. Thank you very much.
Okay, thank you. Professor will take a seat together as we approach the end of our session in this afternoon. I'd like to invite Professor Hu and Professor Christof to share your closing thoughts about digital humanities. As a matter of fact that through this year, through this conference, we have initiative in Indonesia to build a new community, the new association in digital humanities. So we know that Taiwanese Association of Digital Humanities is established since 2016 and become the constituent of ADHO in 2018. Professor Christof is also the president of ADHO today with us. And then the closing remark is, can you share interest in forming an, I'd love to ask both of you that what are your expectations for how our expertise in the humanities can contribute to this initiative? And the case study is in Indonesia. The first, please welcome Professor Christof to share your thoughts, please.
Yeah, so first of all, thanks a lot also for the wonderful talk we heard just now. And I think that the two talks were really nicely complementary. So regarding the question of the associations, I think the example of the Taiwanese Association shows indeed that it is useful and for a community that has been, that has a long tradition of digital humanities and digital history and historical databases to form an association, because that gives visibility to that community within your region of influence, let's say, but also beyond that, internationally, obviously. And the possibility to join ATO is, of course, one of the ways in which a regional or local association can become even more visible internationally. And so I hope that you agree that this was a good step for the Taiwanese Association of Digital Humanities. It was certainly very, very much welcomed by ADHO. We are very, very happy to have the Taiwanese Association as part of ATO. That's a very positive development. We feel very encouraged by new associations joining ATO. And so as I've seen that this is something that is being debated as well at your conference and in Indonesia, I would very much encourage you to follow that path and to maybe hear experience as well from the Taiwanese colleagues. Also recently, the Korean Association has joined ATO. And of course, I'm sure that the ATO Admissions Committee or the ATO leadership will always be very, very much ready to support regional initiatives for associations. So don't hesitate to contact me personally or contact other officers at ATO for support in this really important process. And it's really great to see that this is happening in Indonesia, and I really do follow through with it. It's worth it, I hope.
Yes, thank you, Professor Christof. And Professor Hu, can you share about that?
Okay, thank you, Professor. I will say congratulations to hear that you will have the association for the digital humanity. And in my opinion, I hope if it's possible, we can focus on the education for the next generation about the digital humanity, especially for maybe you can see the students sit over there, right? They are just born in the digital world. So to use digital humanity tools or your digital humanity platform, or even use the tool of AI, it's just like piece of cake for them.
Yes.
So if you have a wonderful tutor plan, you can just put the education schedules in your campus, and to make your student to know how to use these digital humanity tools. And I think they will become a big help for everyone to want to do the digital humanity research in the future. This is my opinion.
Okay, thank you. Danke, Professor Christof, and 谢谢 Professor Hu from the very thoughtful insight today. And your perspective provide an inspiring foundation for our future collaboration, especially in digital humanities. Thank you so much. And this is the end of our keynote session. Very big applause for Professor Christof from Germany and Professor Hu from Taiwan. Very big applause. Thank you.
Thank you to the speakers, Professor Christof and Professor Chijui, as well as Dr. Jureynold as the moderator for the interesting and insightful sessions. To the speaker, you
Tadi juga
kindly
Profesor apa tadi yang Jepang tadi first name-nya.
Thank you. Bye-bye.
Kalau mau lengkap.
Iya, at least last name kan, bukan jadi aneh.
now
Profesor Christof,
we have come to the end of the
Profesor Robert.
session and would like to distinguished guests to have a coffee break. Please enjoy your coffee here in this room at the back, and at exactly 3:15 we will start the second parallel sessions of the conference. Panel session 3 will take place in room 405 and panel session 4 in room 407. For all paper presenters and moderators, please ensure you attend the session on time. The student committee will assist in directing you to the parallel room. Thank you.
Uh, Good afternoon, everyone. Welcome to the online session. For this online session, as you can see in your Zoom link, there's a join breakout a room that you can join and participate. So based on your panel number that you already been assigned, whether you're a presenter or moderator or any participant who are interested to join. So because now the link of the join breakout room is already open, you can start joining it, and then by 3:15 the moderator can start the session if everyone in that session already completed. Good luck for everyone. Have a good discussion. I will be still in this main room if there's any sort of a question that you want to ask. Thank you, everyone. For the one who just got join, if you already can start joining the breakout room, you can start joining through the join breakout room based on your panel, assigned panel, whether you are presenter, moderator, or any participant who are interested to look at or to hear the presentation in this panel session. And so if it's you can see in the join breakout session, there will be panel 7, 8, 9, 10, 11, and 12 based on the program book that has been identified. You can start joining those panel session, and the moderator will start leading the session on time.
Brother, could you just please help me with this panel, this one I have to please.
For Ibu Mel, for Ibu Mel, you will be in panel 12.
Oh, okay. Thank you.
Yes. Ibu Mel will be panel 12.
See you later.
Yes, Pak Daniel. See you. Do you have any difficulty, Pak Daniel?
Join tombolnya nggak ada ya?
Yes?
Tombol join breakout room-nya di saya tuh nggak ada.
Huh? There's a down below the Zoom link, next to the record. Next to the link, next to the record, you can see that there's a join breakout room, and you can participate. Yeah? Did you find it?
Yeah.
Yeah, okay. Is there anyone who still has an issues with this one? Oh, sorry. For anyone who just participate, you can start joining the join breakout room based on your assigned panel, including moderator, presenter and any participant. So if you're if it's based on the program you are assigned to panel 7, you can start joining in the link in the join breakout room session that available under the link in this link Zoom. You can start joining it now because I think some of the session already been started.